Example 5.9 of your book, page 115. What we have is a calorimeter that's used to check the quality of the steam. Steam gets diverted inside the calorimeter, and we can record the pressure and the temperature, and we know what's the pressure of initial of the steam. So the question is, what is the quality of the steam? The calorimeter acts as a throttling device. So what do we know? We know everything about state 2 because this is now is vapor, and we know its pressure and we know its temperature. For state 1, apparently we do have only one information, the pressure. So how do we find the quality? Well, it's easy enough, because the process from 1 to 2, it will be an isenthalpic process. So what does it mean? It means that the enthalpy here and here needs to be the same. We can calculate the enthalpy at point 2, so we can now find the enthalpy at point 1, and with the help of enthalpy and pressure we can determine the quality of our steam. So the process is simple enough. Here we're looking at the information, the equation that's telling us that the enthalpy on point 2 is equal to the enthalpy on point 1. The enthalpy on point 1 it will be calculated as the enthalpy that you would have at this point that we can find, plus the quality, multiply the difference between here and here, this difference, and we have both. We can find it on the table at both this point, so we can easily find what is the quality of our system. The only thing that we need to do is to look up at the values for H2, and we need to find the value for H1G and the value for H1F. Our pressure was 14.7 psi, and our temperature is 250, so the value for H2 is this value over here. Instead, to find the HF and the HG at point 1, pressure was 300 psi, so my values for HF and for HG are this one that are circled. So here are all those values where we just found them. We plug them in this equation, and we find that our quality is 0.957.